And we're just going to have a moment where I double check that the LinkedIn and everything else is showing up like it should. Hi, everybody. If you're seeing this, we're starting up. We'll get started in just a moment here. Yeah, that's showing up live. Awesome. Just a moment here. All I have to do is make sure I'm not actually echoing a bunch of audio around the place. Come on. Thank you for checking us out on YouTube. Thank you so much. Okay. And that's open. And one moment, let me just get the YouTube view open. Awesome. All right. Okay, folks. I think we're ready. Pranay, you feeling ready?
Yes, we are. Let's go.
All right. Thank you so much, everybody, for joining us. This is the first in our series of OpenTelemetry webinars. This is going to be product agnostic. We're not going to come back and talk about signals a bunch, so don't worry about that. I promise this is not an extended pitch. We're just going to talk about high-level concepts, iterations with engineering OpenTelemetry. With me is Pranay, and we are going to be talking about some basic stuff with the OpenTelemetry Collector today. So we drew a couple of questions from the mainly from the CNCF Slack, and those specific questions got answered. So we're not going to be replying to those specific people. And yeah, Pranay, just a little bit of background noise from you. So let's mute your mic while you're not talking. No worries. So we're not going to be answering those specific. We're not going to get into like the individual setup that those people had in question, but because we saw some similar questions like this both on Reddit and on the CNCF Slack, we'd like to talk about them kind of in general and what they kind of lead us to. So the first one was from Mike on the CNCF Slack saying, I'm new to OpenTelemetry. I was thinking that the collector was backed by some sort of data storage, but I'm not finding that. I'm just seeing statements to the contrary, that it just fans in the data and passes it on elsewhere. And I think this is often a kind of one of the places that a beginner starts is saying, hey, I thought that OpenTelemetry was a whole project from collecting data all the way to like presenting a cool dashboard with all your metrics and maybe even sending you like alert emails, but that's really not the reality.
That's true. So
go ahead.
Yeah. So I think one thing which people like maybe don't clearly realize that OpenTelemetry is primarily focused on the instrumentation SDKs, where how you send data from applications to the collector, and then basically sending from data from collector to other backends, etc. So that's where sort of the scope of the project stops. And they don't get into things like data storage, visualization, or like how do you set alerts, right? So all the things which like the SRE engineers or DevOps engineers use day to day to sort of configure things out. So just to lay this out in the OpenTelemetry Collector landscape, right? So the OpenTelemetry Collector can be be thought of a data pipeline processor. So you get some data, and then basically you do some processing, and then you format it and then export it to other backend sources, right? So the three key components of OpenTelemetry Collector are receivers, processors, and exporters. There's a new component also coming. Ball connector will not get there, but receiver, processors, and exporter, these are the three components. Receiver basically gets data from different sources which you want. You can send traces from your applications. You can send logs. You can send metrics. You can do some processing on that. For example, you want to strip it out of PII data. You want to edit some fields, etc. So processor helps you does that. And then exporter basically sends that data to other sources. It can be a vendor backend. It can be open source projects like Signos, Grafana, where you can visualize it, or like it can just be databases like ClickHouse, right? So what OpenTelemetry Collector doesn't do, or like what OpenTelemetry project as such doesn't do, is it doesn't get into data storage. So it gets data from applications, uh, processes it, and then makes the data ready. But the onus of storing it, making, and like the front end dashboards which you see, which projects like Signals and Grafana provide, that is not part of the scope of OpenTelemetry project as such, right?
Yeah, I think
And
there's like even a little further than that. When we talk about like the OpenTelemetry protocol, it's not fussed with like how that data is stored, right? The
Yeah.
OTLP is just about right encoding, transport, and delivery, and doesn't imply like, hey, this will be stored relationally in the following way, right? Like how rich, obviously, how rich like logs or events are stored, or how spans are like collected and connected into traces. That's not part of like the OTLP standard.
Yeah, so OpenTelemetry specifies the wire format, and then any backend or any storage layer which understands that can sort of store that and play with that, right? So yeah, I just wanted to make this clear because I think that is a sort of confusion for many people in the community, that hey, we have heard of OpenTelemetry as a project which does observability, but like can I get dashboards from it? No. So you have to use some other open source projects, other vendor backends to sort of do that part for you. Can you store data? Like, does it take care of storing data? No. You have to use backends or data stores to do that, and then visualize on top of that. So
Yeah. And I mean, there's definitely some opinionation, especially when we get into processors and exporters about how data is going to be stored, and definitely can help with like making sure that your data is like relatively efficient, both in how it's finally going to be stored and how much bandwidth it's using when it's sending. So like, obviously this will help you like batch data, compress it. You do things like averaging metrics with processors as well, right? So you reduce the number of metric sends. But yeah, it's not specific about how it's going to be stored at all.
yeah, so yeah, let's maybe get to the next part.
So yes, this is another question which we're not going to get into like the specifics of, but think a little bit just about in general. So Harsh Thakur asks on again on the CNCF Slack, I'd like to use OTLP gateway, but I have this issue on finding fault tolerant way of getting into Kafka. If I set up an OpenTelemetry collector on the server side to receive OTLP and then export it, I'm afraid those OTel collectors would be a single point of failure. And this is a fairly specific question, but it is something that we like often get to when having these discussions about engineering with the collector, where it's like, hey, I'm starting to get worried about sort of where the collector sits in the architecture. And in the thread that follows up with this, is sort of becomes a little clearer, like it's quite an engineering thing to try to actually have like OTLP data go into Kafka and come back out. And by the way, I apologize if there's typos with OTLP on here. That's probably my own typo when I was retyping the question. I'm not trying to put Harsh on blast with misspelling it. That's probably my fault. Apologies. Just realized that I was reading it out loud, so sorry about that. But so there's often these questions that come back to like, hey, how do I, like, I'm really worried about, I have maybe something really far away on my cluster and it's sending to my collector that I already set up, and I'm worried that there are going to be errors there, there's going to be lag there, I'm worried about creating a bunch of internal network traffic. And then it's like, well, can I set up a queue or some other service inside my architecture to do that? And my understanding is generally that's not necessary, because generally people don't realize like one collector can talk to another. But talk about some sort of basic architecture considerations with the collector.
Yeah, so I think this is a good topic which we can dive deep into. So the idea is that, hey, like we have OpenTelemetry Collector, and then maybe we are potentially using some storage backend for it, right? But what are the different ways in which the apps and nodes and like can interact it, like can send data? So I'll try to cover some details on that and maybe discuss more on that. It's more of an introduction to different some of the patterns which we have seen, and then maybe if there's more interest, we can get into more advanced topics like gateways and load balancers in one of the coming sessions. So yeah, so let's get started. So one of the basic patterns which we have is, hey, I have some. So this is the OpenTelemetry Collector, and then maybe you're using a storage backend and you have a visualization layer which you can can talk through data through that, and then you can make dashboards around there, right? But if you have, for example, applications, for example, if you have a JavaScript application, one common pattern is to send data directly from that application to the OTel collector, right? So you install an OTel collector, and then you get an endpoint for that, and in your applications you directly specify those endpoints and start sending data directly to that, right? So this is one of the patterns which people generally get started with. It looks pretty simple, right? But so what are the pros and cons of this, right? So one thing is that it's very simple. You can just get started in a dev environment and then get moving. There are no other OTel collectors which you are operating in the application flow. The OTel collector is primarily at the observability layer. So you have a one main central OTel collector, and that's where you're sending your data from, right? So it's simple in that way, but some of the disadvantages of this approach is that, one, if you want to make any code changes, etc., if you want to do any changes in collection, ingestion, then you need to do changes in the code, because that is directly tied to the application. In the application logic, you're changing that. And in some teams, the responsibility of managing applications is in a different team, and the DevOps team or the SRE team is a different thing, right? So generally, what I've seen, this is a good approach to get started with, to test to start testing and sending data to you, but it is not generally used in production. So because there is a strong coupling between application code and backend, and so what's the next approach, right? So something which you can, yeah. Nica, you're on mute.
She's on mute, folks. I just want to say, I often think of this solution as being like the developer solution, where it's like, hey, I'm a developer. I'm excited about monitoring my application more closely with OpenTelemetry. And so it's like you maybe have someone stand up a collector for you, or you work your way through it, but then you're able to experiment with your application code and instrumentation on your application side and kind of see the results pretty quickly. And it's great for that kind of loop where it's like, ooh, I want to maybe do like a really custom instrumentation thing and experiment with that really quickly. But yeah, when you're saying, hey, I want to instrument all 23 microservices and have everybody get on board, you really don't want to be going to the entire dev team being like, hey, everybody, go in and edit a bunch of code to send data in a different format, because we're not collecting it just right, because I can't do anything about that otherwise. That starts to be like a lot less clean and efficient. So yeah, great place to get started, but not too often do you see this. You see this almost as rarely as you see no OTel collector, where it's just sending data right to the back end.
That's true.
All right, back to your slide. Now we're back on your path.
Yeah. So if that just sending directly from applications is maybe have some issue, that was as we discussed, what else can we do, right? So one common pattern which you've seen is, especially for people who deploy things on virtual machines, is you run an OTel collector in each virtual machine, and that essentially acts as an agent. So if you have multiple applications which are running on the virtual machine, the applications there send data to the OTel collector in that machines, which is acting as an agent, and then all such OTel collectors in the machines send to the central collector, right? Couple of advantages of this approach is that, one, it's simple to get started. You know that, okay, I have to install one OTel collector, and there's a clear mapping between the applications and the OTel collector. So okay, this application is sending data to this OTel collector, and if you want to do processing there, or do any things like PII data or sampling, PII data removal or sampling, that can easily be set up on a node level, right? So one of the disadvantages of this approach is that because you are manually setting up OTel collectors in each node, you need to sort of manage that process yourself. That, okay, I am setting applications, and then these OTel collectors are running on these nodes, and then they are sending data to this OTel collector, right? So this, like the OTel collectors in the nodes need to be set up by you and then configured properly. So that's sort of the one disadvantage, but this is a pattern which is used a lot, using agents and then using that to send data to the central collector, right?
Yeah, I'm sorry, go ahead.
No, I was just going to say that even in many vendors, you generally see that they ask you to install an agent in the VM, and then that sends data to their endpoint, right? So this is very similar to that sort of approach.
Yeah, I think one of the things we're kind of eliding here, but is usually present, is that this like first green arrow, this first green send, is often associated with some cost. So having these collectors to the left on these virtual machines gives you that chance to like batch, debounce, right, and compress and collate a little bit your data to save you a ton of money if you're really spending on this send. I think often these are kind of drawn to scale, these three collectors, where it's like the ones running on the virtual machines are usually pretty minimal, right? They may just be batching data, maybe have your most critical PII settings. Like, oh my God, if you see, a credit card number or a social security number, go ahead and, pull that out. But otherwise, a lot of that config, a lot of that complexity is happening on the other side to be like, here's how you stitch together traces, or here are these other kind of very sophisticated processing steps. Because you don't want to have to tell everyone with every virtual machine, hey, go in and add this config and add that config. You just manage it on your central secondary collector.
Like one reason why sometimes this approach is essential is, for example, if you are interested in getting infrastructure metrics, right? So you want to get the infrastructure metrics of the virtual machine. You need to run something on the node level to get those metrics, either in terms of the node. For example, if you're running Prometheus or you're running host metric receiver, you run that at the node level and send data to this OTel collector, which is running on a virtual machine, right, at the node level. Or if you want syslogs of a machine. So generally the approach people take is you forward all those syslogs to the OTel collector in the machine, and then you send that to the main central OTel collector. So yeah, sometimes this becomes important and like essential. Let's get to the next. So yeah, I think we have discussed this on like what are the advantages. Let's get to some of the patterns which are also common in the Kubernetes world. So there are like a couple of patterns which are generally used. So one of them is running the OTel collectors as sidecars with each application pod. So in this approach, with each application container, you also run a OpenTelemetry Collector container, and basically that container sends data to the OTel collector, right? What this helps you do is that for each application, there is a OTel collector associated with it, and so you essentially are agnostic of what the backend you use. So if you have OTel collector here, then you can just configure that to point to the, like this OTel collector is, suppose you are using Jaeger today or Signos today as the backend, and what you just need to do to change the backend is to change the endpoints or the exporters in this OTel collector. Whatever is you have done here remains, like in the application pod, remains same. So that's one of the interesting parts of this type of OTel collector, right? By the way, I've just shown like this in the sidecar pattern. For example, just to take an example, the things which you see in the dotted green light is what comes with Signos. So if you are running instance of Signos yourself, it comes with a central OTel collector, storage backend, which is ClickHouse in our case, and then the visualization and the query layer, right? So basically, the OTel collectors which are running as sidecars point to the Sigdal's OTel collector, and that takes care from there.
Yeah, I think this is one of the things where you see why maybe some vendors who are out vending previously, maybe selling like closed source SaaS observability, are a little bit nervous about the existence of the OpenTelemetry project, right? Like there's definitely an effort to like embrace those standards, but then there's also a little bit of concern. I think one of the reasons is this very basic thing of like, hey, you can just configure this to send to a different, OpenTelemetry endpoint, right? And so, yes, of course, they're going to have very different advantages and disadvantages, and tools like Prometheus and tools like Jaeger are going to have totally different like use cases. But I think there is some nervousness in the SaaS world. It's like, hey, if you get this running in a config like this, it's very, very easy to have all of these sidecars hitting the same point for a config file, right? Getting, hey, this is where we're sending our data. This is the right side collector that we're sending to. And then, the process of migration should be pretty straightforward, right? Because you can just say, hey, I think this will do better visualizations. This will take a better look at my traces. The storage makes more sense on this platform. And then you can just configure away and be migrated onto somebody else. So, I this is not to get all like industry insider, but like I think that is one of the reasons why we say, hey, this is definitely worth exploring, because it's not that fun to be getting some nice observability data and then discover like, no, I am stuck with this vendor. There is no way to see anything like this, with any other tool, and certainly not with an open source tool. So that's one of the great things about using OpenTelemetry and the OTLP standard fully.
Yeah, I think essentially what the OpenTelemetry project has done is democratize the instrumentation layer, and I think that's very sort of fascinating. And then a lot of projects can offer, for example, projects like Signos can be as a backend and just built on top of the OpenTelemetry collector, right? Just getting back on this topic of sidecar patterns, right? Some of the things which you can do because of each OTel collector being tied to a application, you can do much more better fine tuning of like how much OTel resource you want to allocate to this OTel collector. For example, if you have an application which is sending a lot of data, or like needs, or is an important application, and you want to monitor it well, then you can assign more resource to those OTel collectors which are attached to that application pod, right? And so this pattern gives you much more configurability, or better configuration ability of the OTel collector for each of the applications separately, right? And then because all of these OTel collectors are acting independently for each of these applications, if you are running the system at a scale, generally the load balancing is much easier, because if the OTel collector in the observability system is scaling, what you want to do is ensure that all these systems, or all these pods in the OpenTelemetry collector which are in the application pod, are able to scale much faster, because they are independently sending data to the OTel collector. And because the aggregation level happens at the application level, that traffic sorts of smoothen out, and it's much easier to handle higher workloads, right? The only disadvantage, or like one of the disadvantage of this, is because you are running an application pod with each, like an OTel collector with each of the application pod, you are just running so many of them, and that reach to higher resource requirements, right? So generally an OTel collector should run within 5 to 10 MBs, and then if you say are running 100 pods, that sort of scales up. But
if you're really running nano services, maybe you need to start worrying about that. You've pushed beyond the micro threshold. Oh, and we have, cool. Let's talk about this. Let's talk about this last model here.
Yeah, so I think sort of this is a trade-off between the application sidecar pattern and and this is sort of the second pattern which you saw in the VM world, where OTel collector is running at a node level. So basically, this is the demonstrate patterns in Kubernetes, where rather than running things with each application pod, you are running one OTel collector each on each virtual machine, right? And what this does, it gives you flexibility enough to control things at the node level, but at the same time, there are like not as many application pods, so like the amount of resource requirement is not as much, right? So the other advantage is that because you're still running the OTel collector very close to the application pod, so the application can just offload data much easier rather than sending it to the, say, central OTel collector via network, right? So you're still within the confine of your private net of the machine. So the application offloads data very easily, and then the OTel collector in the node has the responsibility of sending things to the central OTel collector, right? What you lose with this setting, and the trade-off here, is that because there is only one OTel collector in each node, you lose the fine-tuning capability which you talked about. For example, you can't resource allocate for a particular OTel collector based on a particular application pod. It needs to be based on the whole node, right? So
yeah, so if you have a single pod that's like sending a crazy amount of data, you're like, oh, I want to go in with the processor and clamp down on the amount of data that's being sent. It's like, well,
yeah.
I mean, it's theoretically possible. Maybe you can do it based on how the data is being tagged, but just not as easy to say. We sort of have very different collection strategies for the different pods that are running within this cluster. That's not as easy to do.
Yeah, and like one other thing, subtle point here is that because you are running things like at the node level, so it's difficult to do application level multi-tenancy here. So for example, if you want to run something where different applications belong to different tenants, that's difficult to do here because again, because there's a single node here, and hence you can't like do different sampling for each tenant or different resource allocation for each tenant. So yeah, basically that's the trade-off.
We have a great question that just came in via chat, and I've thrown up on the screen here. How could we have a push-based system where the new pod will push the metrics and logs to a common collector? So help me parse push-based system here, because I want to make sure that we're answering this question well.
Yeah, I think push. So basically, there are two systems which can happen, right? Either it's a pull-based system or a push-based system.
Okay.
So generally, Prometheus is one of the formats which is famous for the pull-based system. Basically, what happens in the case of Prometheus is that you expose data at a particular endpoint, and then you have a Prometheus basically scraper which goes ahead and then scrapes that endpoint, right? So that's a pull-based system. That's a pull-based system. And push-based system is basically like you have some data and then you are sending that data to for example, the OTel collector, right? For example, this is the default mode in which OpenTelemetry SDKs work, that you have some data and then you have a queue in that, and then you push that to the collector.
Yeah. So I think, in general, right, if you're going in and doing config on your new pod to say, hey, here's the collector location, here's the OpenTelemetry SDK. Let's say it's a Java pod, it's running a Java application, and you go and configure it with the Java OpenTelemetry SDK. That's going to work great. I think another part of this question is like not exactly discovery, but we want this to just happen, right? When we spin up a new pod, we want to expect that it's going to be pushing data to the collector.
Yeah. Regarding this question, I am not very clear. So how can we have a push-based system where the new pod will push the metrics and logs to common collectors? So I think the default way in which OpenTelemetry works is push-based. So, for example, if you're using host metrics receiver in OpenTelemetry, then, for example, in this pattern, right? If you have this pattern where we have a hotel collector running in a virtual machine, and you want to, for example, get the host metrics, that is by default, as far as I understand, is a push-based model where the OTel collectors take this metrics and then push to the OTel collector, the central OTel collector. So,
and you should be able to configure, and this is something I've been thinking about writing about. And so I promise, commenter, that we'll probably see some documentation about this in the next few weeks. Is like you should be able to do lookup within your cluster to like go and find your collector and like start reporting to it automatically with new setup. It's the whole process of like auto instrumentation and just adding OpenTelemetry, an OpenTelemetry SDK as a dependency. That's your mileage is gonna vary a little bit on that depending on your language and framework, but it is possible. We do have a couple of like use cases that I'm aware of where like somebody says, oh, I'm going to deploy my Rails application, for example, go to deploy it in a new pod, and it actually just goes ahead and grabs the Rails SDK, sets up auto instrumentation, and is immediately reporting to the right collector, because you should be able to look up that collector locally on your cluster.
Yeah.
But yeah, that's a great question. Thank you so much for running that in. This very very topical. So, but by the way, if anybody else has any other questions in chat, we're going to be wrapping up shortly. So please drop them into chat, and we will actually see them and respond to them.
Yeah, I think let's try to finish. So we discussed about the demonstrate pattern and why sometimes multi-tenancy might be difficult to configure here. One thing which I want to point here is, especially for the Kubernetes world, is OpenTelemetry operator. I think many people are not aware about this. So just a second.
Yeah, the OpenTelemetry operator is not the most like well understood or super popular thing. So definitely worth talking about.
Yeah, so if you are in Kubernetes world, this concept called operator, you must be aware about. So what OpenTelemetry has done is it's given out default operators which you can run in your Kubernetes cluster, and currently it provides 3 deployment modes. One is like the deployment mode where like it runs overall over the whole Kubernetes cluster. The second is the sidecar mode, which we talked about, where it's like a collector is tied to a particular application pod, and the third is the demonstrate mode where it is tied to a node, right? So if you see this graph, right, so here we have like a single pod, and like here we have multiple application pod. What happens is if you have multiple, say 100 of such application pods, right, it becomes difficult to manage the OTel collector pods. So you have a bunch of OTel collectors running. How do we manage them? How do we ensure that if they are dying, they are coming up again, and like they are resource allocated properly? So that's what the OpenTelemetry operator does. You can specify if you want to run this OpenTelemetry operator in deployment mode, sidecar mode, and demonstrate mode, and then it will, for example, in sidecar mode, it will automatically inject the instrumentation SDKs and then start reporting data to you, right? So I've added a link of a tutorial which we have on our site also of how you can use this. But if you're in Kubernetes world and are exploring OpenTelemetry, do check this out. For most of the languages, at least for JavaScript, Java, Python, the auto instrumentation works really well, and you should be able to get started very quickly.
Yeah, this is a very powerful tool, and definitely gets some real traction with what's possible. And actually, we have a couple more questions. Oh boy, this is so nice. This came in right here at the end. Thank you so much, folks. So, oh man, we got 3. All right, well, let's get started. I was just dropping the link in the chat, which you'll see shortly here. But can you touch base, please, on the resiliency part? OpenTelemetry Collector downtime, we lose data, right? Even though we're running multiple pods, during the switch, we lose some data. So at the top level, yes, right. All these do. There's a single collector involved at one point. So while that collector's down, in general, right, you're going to be missing some data during that time. Other considerations about this, very often these like relatively quite short outages are not usually the hugest concern. But can we talk a little bit about this?
Yeah, I think if you look at this chart, right? Or or even just to make things simple, if this chart, right? So for each OTel collector, there's a queue on top of this, and generally, like I've called this just as a single OTel collector, like a single block. But people, you generally, because OTel collector is horizontally scalable, you generally run a fleet of OTel collectors here. So in the observability section, the common OTel collector is not generally a single OTel collector. It's a fleet of OTel collectors running, and you have queues in front of it, right? So a lot of the resiliency comes from like the horizontal scalability of it and the queue which is associated with it. Though sometimes if like the outage is much longer, one of the recommended patterns is to get a Kafka queue or like some other sort of queue in front of the OTel collector, so that like even though the OTel collector is down, you can get like have some data, like time of data which you have, right? So that is one of the pattern which you have seen. Nika, I think this might be a good topic to dive deeper into, like how this works, because here we have taken an example of a single OTel collector, but the OTel collector here is not a like generally not a single OTel collector. It's like multiple OTel collectors running as a fleet. So even if one OTel collector is down, you have a load balancer in front, which sort of redirects to the other OTel collector.
Yeah, and in fact, the next question that we have goes back to a question that I'd highlighted for this week, but we'll be talking about probably next week or the week after. Right? Is it possible to use Kafka in front of the central collector to provide some resiliency in case the backend that central collector goes down? And so this is a great. I think we're going to cover this more in depth in a future version. I think the short version is. Yes, it is possible to use Kafka. There's a great deal of lift there because OTLP is not like super native there, but there is definitely a bit more resiliency than you see right in this initial version of this chart. Let's get back to that one about resiliency and kind of the advanced conceptualization of that. There's another great question. We're sort of swapping topics a little bit, but I promise we will talk more about resiliency and single points of failure. Is there any OpenTelemetry operator available for EC2 host metrics in specific? And the answer to that is not exactly. It's not necessarily going to pick up. There's not like a build of the OTel operator, the Kubernetes operator for EC2. There is the ADOT collector, which is the AWS distro for the OpenTelemetry collector, which does grab some specific EC2 metrics directly, and has a couple of other specified pieces, including like a receiver for X-ray data and some other AWS specific stuff. So I think that's probably what's worth checking out is that specific distro of the OpenTelemetry collector. And I'll share a link to the ADOT GitHub in chat here.
Yeah, maybe just check this OpenTelemetry Collector receiver repo. It has like listed out all the receivers. I'm not sure of if are there any operators specifically available, but the host metrics receiver comes by default. And yeah, maybe this is a link for checking out.
Yeah, so yeah, actually, I probably should have started this. Is a lot of what you need for like EC2 monitoring, you're going to get just sort of directly on host metrics from a default collector, and then yeah, checking out the OTel collector's receiver libraries right there. There's going to be more there, and then also sharing this link to the AWS version of the OTel collector, which is a little more specialized into like you're probably doing some of the CloudWatch stuff that you want to adapt over to OpenTelemetry as well.
Yeah.
But yeah, we may do, you know, if there's more questions on that, especially we'd love you to hop into our like community Slack and discuss this a little bit further. We would love to talk about this a little further, especially if there's a lot of interest in specifically doing this on AWS. That's its own topic, so that's I think worth talking about. But yeah, if you're seeing this on LinkedIn, do go ahead and give us a follow there. You can go ahead and subscribe and hit notifications on YouTube if you're watching this on YouTube, and then also we'll share in our community Slack and on CNCF events when we're doing the next one. Do we have other kind of final thoughts or stuff we wanted to share?
No, I think this is great. I think we have lots of good questions, and
Yeah.
we also have got some good questions on like what maybe we can chat more. And if anybody is interested, like we are quite active in a Slack community, so just join us there and like we can continue the conversation there.
Yeah.
So, Nica, do you want to share the Slack community links?
Yeah, I just dropped those in the chat. Oh, it's looking like they're getting filtered. I'll fix that in just a sec. And also, if you're watching this on replay later, we will share the link to the Slack down below as well. There we go. There's one got sent. I think maybe you did that one. Let me see if I can get that to send to the LinkedIn chat as well. Oh, that would be so cool if that just worked. Not quite. I'll get it working. We'll share a link down below as well. But yeah, signas.io/Slack. We'll take you to it as well. Thank you so much for joining us, everybody. We're going to wrap it here. Again, if you have questions, feel free to add them as comments on the video, especially for future episodes, and we will talk soon.
Yeah, thanks a lot. Bye-bye.